Welcome back, guys. This is question 6.11, and the statement of this question is a soft drink machine is regulated so that it discharges an average of 200 milliliters per cup. Okay, so the average is given. If this amount of drink is normally distributed with a standard deviation equal to 15 milliliters, so on the basis of it, we are asked to find the questions given in part A, part B, part C, and part D. So let us solve it first. So in solving it, let me first find here the given data, and in given data the value of mu, which is the mean, is 200 milliliters per cup. So 200 milliliters per cup. Okay, and the standard deviation, which is sigma, that is 15 ml. Okay, so this is the given data. On the basis of it, let me solve different parts of our question. So part A of it is, what fraction of the cups will contain more than 224 milliliters? Okay, so we want to find out the fraction of the cups which will contain 224 milliliters of the soft drink. Okay, so what is this? Basically, it is the real life formulation of the questions which we have previously solved. So therefore, if we will neglect the milliliters, so what do we want to find out? We want to find out the probability that x, or the amount, is what? X is greater than 224. Okay, so in order to find this probability, we need to consult what? We need to consult the z distribution table. So therefore, this value should be converted to the z value. So therefore, in order to convert it to the z value, we know that z is equal to x minus mu divided by sigma. So let me put all these values. So x is 224 minus mu is 200 divided by 15. Okay, so this would be 24 by 15. So let me have it here, 24 divided by 15, this is 1.6. Okay, so 1.6. Therefore, we want to find out the probability that x is greater than 1.6, but the formulation of the z table is basically on the basis of the x is less than or equal to 1.6. So therefore, in order to find it out, we have to find the value in the z table and subtract it from 1, and therefore we would get this value. Okay, so let me find it out. 1.6. Okay, so let me move to the z table, and here the value 1.6 is where? Let me search for it, and 1.6 is, this is the 1.6, and this is the first column because this is 1.60. So therefore the value we will have is 0.9452. Okay, so let me write it, 0.9452. Okay, and let me subtract it from 1. So 1 minus 0.9452, so this is 0.0548, 0.0548, and this is around what? This is 5.5%. Okay, so means the 5.5% of the cups will contain more than 224 milliliters. Okay, so that is what, that is basically the solution of part A of our question. So let me remove it and let me move to part B. So in part B, what is the probability that a cup contain between 191 and 209 milliliters? So we want to find out the probability that x is greater than 191 and less than 209. Okay, that is what we want to find out. So therefore, this value is what? Let me call it z1 and let me call it z2. Okay, and let me first find them, and then after finding them out, what would we get? It was, let me have it, legs x is greater than z1 and less than z2. So after it, we would do probability that x is less than z2 minus the probability that x is less than z1. Okay, so we would do it. So therefore, in order to do so, we don't know the value of z1 and z2. So therefore, the value of z1 is x1 minus mu divided by sigma. Let me put the values here. So x1 is here 191. This is x1 and this is x2. So let me put these values. So 191 minus 200 divided by 15. So it would be minus 9 over 15. It is what? So 9 over 15. This is 0.6 or minus 0.6. And the value of Z2 is x2 minus mu divided by sigma. So the value of x2 is 209. So 209 minus 200 divided by 15. So this is again 9 by 15 and this is plus 0.6. So therefore, we want to find out the probability that x is greater than minus 0.6 and less than 0.6, and therefore using the same formula which is here, we would have to find what? We would find the probability that x is less than 0.6 minus the probability that x is less than minus 0.6. Okay, let me find these values from the z table. So in the z table, 0.6 is how much? This is 0.6 and the value it has is 0.7257. So 0.7257 minus for the value of minus 0.6, it would be minus 0.6 is here. So it is 0.2742, 0.2742. Okay, let me subtract them and here it would be 0.7257 minus 0.2742. Okay, so the value it has would be 0.4515. So 0.4515, which is around 45.15%, and that is what? That is basically the solution of part B of my question. Okay, so this is the probability and this is the percentage. Okay, as we were asked to find the probability, so therefore this is the answer. So that is for part B of my question. Let me remove it. In part C, how many cups will probably overflow if 230 milliliter cups are used for the next 1000 drinks? Okay, means the probability that X is greater than 230 milliliters, this is the threshold amount, and the amount which exceeds it is basically the overflown amount. So therefore it would be what? It would again be the conversion to the z distribution table. So therefore z would be equal to x minus mu divided by sigma. So x is 230, mu is 200 as given here. So 200 divided by 15. So this is 30 divided by 15, which is 2.0. Okay, so the value of z is 2.0. So therefore, this is the probability that x is greater than 2.0. And as we know that z distribution is constituted in terms of the formula, which is x is less than 2.0. This is for the lesser value. So therefore, in order to find this value, we have to first find this one and then subtract it from 1. Okay, so let me find it out, this value. So it would be x is less than or equal to 2.0 because this is the continuous distribution, so we can use both of them. So let us consult our table. So 2.0 is where? This is the 2.0 and here the value is 0.9772. So 0.9772 0.9772. Okay, subtracting it from 1 minus 0.9772. Okay, so this is 0.0228, 0.0228. Okay, so this is the probability value. X is greater than 2.0. Okay, this is the probability. In order to find the number of the cups which will overflow from the 1000 drinks, that would be what it would be the chance of the overflow multiply with the total number of cups, which are 1000. So therefore it would be 22.8. Okay, so which is around 23 cups. Okay, so that is basically the solution of part C of my question. Let me move to part D of my question. In part D, we have to find that below what value do we get the smallest 25% of the drink. Okay, so that is part D, and this is what, let us find it. This is the distribution. This is the distribution we have, and the mean value of it is what, that is 200. Okay, and the standard deviation it has is 15 milliliters. Okay, now we want to find out what we want to find, that what value do we get the smallest 25% of the drinks. So the lower 25% are, let me have here. Okay, so let me have here the lowest 25%. So this is the lowest quartile or lowest 25%, and for it we want to find out this value. Okay, we want to find out this value, that lower than this we will have the less than 25% drinks. Okay, so therefore we have here what, let me have here the standard distribution. So for it, if we have x is less than x1 in this distribution, so in Z distribution, where we would have all of these in terms of what it will be here, and here the mean value would be 0, the standard deviation will be 1, and here we will have this Z1. Okay, we want to find out this Z value, so therefore it would be here. This is for this one, and for it we will have x is less than Z1, and this is what, again this is 0.25. Okay, so this is 0.25, and for finding this Z value we would have to do what, it would be the inverse of 0.25. so let me find it in the distribution table, that what is the Z value which corresponds with this 0.25. so let me search for 0.25. so this is the value which is 0.2513. so the value it corresponds with minus 0.6, and the column value here is 0.7. so this is minus 0.7. okay, so the value of Z1 is minus 0.67, which is of this value. Okay, now in order to find out this value from it, what do we have to do? We know that Z is equal to x minus mu divided by sigma. So therefore the value of x is what, this is mu plus Z multiplied by sigma. We know the value of mu, that is 200. We know the value of Z, which is minus 0.67. okay, and the value of sigma is 50. okay, let me find it out. so it would be 0 minus 0.67 multiplied by 15, 0.67 multiplied by 15. so this is 10.05, and subtracting it from 200, 189.95, and that is what, that is basically the value which should be here, and that is the solution which we wanted to find. Okay, so that's it for today, in which we have solved question 6.11. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 6.12 and 6.13, and as these two questions are closely relevant with each other, so therefore we are going to solve them in this video. So the statement of question 6.12 is the loaves of bread distributed to local stores by a certain bakery have an average length of 30 centimeters. So the average is given and standard deviation of 2 centimeters. Assuming that the lengths are normally distributed, what percentage of the loaves are A, longer than 31.7 centimeters, mean the probability that X is greater than 31.7 centimeters. B is between 29.3 and 33.5 centimeters, means the probability that X is greater than 29.3 centimeters and less than 33.5 centimeters and shorter than 25.5 centimeters, mean the probability that X is less than 25.5 centimeters. Okay, and it should be known here that the value of mean is 30, the value of sigma, which is the standard deviation, this is 2. Okay, these are in centimeter, all of these quantities are in centimeters. So what to do here, because these are the values of X, so first of all we have to convert them into Z, and then using the Z distribution table to find out the values, and then we will write them here. So let me first write the formula for Z. So for Z we know that Z is equal to X minus mu divided by sigma. Okay, so solving them here for each of one, for this 31.7 centimeters, we will have the value of Z is 31.7 minus 30 divided by 2. So this is 1.7 divided by 2. So 1.7 divided by 2 is 0.85. Okay, so therefore this is equivalent to what? Let me use this color for the Z. So probability that X is greater than 0.85. Now the value has been transformed from small x to Z. Okay, but now we have difficulty in solving it, because in Z distribution table all the values given are in terms of the probability that X is less than some value. So therefore if you want to find out the value greater than it, we will have to find out the value that X is less than 0.85. Okay, and we'll subtract it from 1. Okay, so let me solve it, and it would be what? It would be 1 minus probability that X is less than 0.85. So let me use the table 0.85. So this is 0.8, and the column for 5 is here, this one. So 0.85 is 0.8023. So 0.8023. Okay, and subtracting it from 1, it would be 1 minus 0.8023. So this is 0.1977. So this would be 0.1977, and that is what? That is the solution for part A of my question. Okay, so this was for part A, and now moving towards part B. Here the values of X are these. We have to convert them to Z by using the same formula, and there we will get Z1, Z2. Okay, by using the same formulation, which would be X1 minus mu divided by sigma, and X2 minus mu divided by sigma. Here the value of X Z1 would be 29.3 minus 30 divided by 2, and here it would be X2 is what? X2 is 33.5 minus 30 divided by 2. Here we will get 0.7. Okay, minus 0.7 divided by 2. So this is minus 0.35. This is for Z1, and for Z2 we will have 3.5 divided by 2, so it would be 1.75. This is for Z2. So therefore, this formula would become what? It would be, let me use this blue color. So it would be for the x, we will have x is greater than minus 0.35 and less than 1.75, and this would be the probability that x is less than 1.75 minus the probability that x is less than minus 0.35. You have to find these values and then write the answer of it. Let me write them here. So probability that x is less than 1.75, so this is here 1.75 is, this is the 1.7, this is the 1.7, and the fifth column is here. So 0 0.9599, 0 0.9599 minus probability that x is less than minus 0.35 minus 0.35, so minus 0.3 is here, this is minus 0.3, and this is the fifth one. Let me see, is it the fifth one? Yes. Okay, so 0 0.3631, 0 0.3631, subtracting it, let me subtract them. So 0 0.9599 minus 0 0.3631. Okay, so here it is 0 0.5968. So 0 0.5968, and that is what, that is basically the solution of part B of my question. For this one, it is very easy. First of all, you have to convert it to Z as well. Okay, so let me convert this value to Z by using another color. Let me use this black color here. So the value for it is Z is 25.5 minus mu is 30 divided by 2. So this is what? This is minus 4.5 divided by 2. So therefore, the value of Z would be minus 2.25. Here the value is what we know. So therefore, this one has been transformed from 25.5 to the probability that x is less than minus 2.25. Okay, so therefore, now let us move to the table and find the value for the value of Z, which is minus 2.25. So minus 2.25 is, this is minus 2.2, and the 5 is here. So this is 0.0122. So 0.0122, and that is what, that is the solution of part C of my question 6.12. Okay, so that is for the question 6.12. Now let us move to question 6.13, and what to do here, we will have to follow the similar steps what we have done for question 6.12. But what is the statement? A research scientist reports that mice will live an average of 40 months. So the average value is given when their diets are sharply restricted and then enriched with vitamins and proteins. Assuming that the lifetimes of such mice are normally distributed with a standard deviation of 6.3, sigma is also given. Find the probability that a given mouse will live more than 32 months, means the probability that x is greater than 32. Less than 28 months means the probability that x is less than 28, and between 37 and 49 means x is greater than 37, less than 49, and that is what, that is the probability. Now what would be the steps? Here again you have to convert it to the Z, this one to the Z as well, as here this is the first one, x is greater than 32. Okay, so therefore the value for C here would be x minus mu divided by sigma. The value of x is 32, the value of mu is what? That is 40 divided by sigma. The value of sigma is 6.3. Okay, you have to find it out and then you will write it here, and here writing it we would get what it would be. X is greater than some value which is z, and that value is minus 8 divided by 6.3. So 8 divided by 6.3, so that is 1.27. So here it is minus 1.27, so here it would be minus 1.27 as well. So in order to find it out, we will have to find the value for x less than minus 1.27, because the z distribution table is in terms of this one, and then putting this value, subtracting it from 1, we will get the answer, that is 0.8980. Okay, so that is the solution of part A of my question, which is here. Less than 28 months means, let us move down somehow. This is part B. So we need to find out the probability that X is less than 28 months. So therefore, let me find the value for Z here. So that would be X minus mu, which is 40, divided by 6.3. Okay, so here it would be minus 12 divided by 6.3. So 12 divided by 6.3, here it is what? It is 1.90. So this is minus 1.90. So therefore here in transformed form it is x is less than minus 1.90, and finding the answer of it here, let me find here minus 1.9 and this is 1.90, so 0.0287 to 0.028 what 72, and that is the solution of part B of my question. Okay, in part C it will be the similar one as that of the part C of question 6.12, in which the value of x would be in between 37 and 49. Okay, you need to find out the value for z1 and z2 for this value x1 and x2 by using the similar formula which is here. Okay, this is a similar formula, and then what would you do? You will have to use the value which is x is less than z2 minus the probability that x is less than z1. Okay, and by putting values here you will get the answer of part C, that is 0.6080. You need to give it a try and tell me if you understood the essence of these questions or not. So that's it for today, in which we have seen the solution of question 6.12 and 6.13. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 6.14, and the statement of this question is: the finished inside diameter of a piston ring is normally distributed with a mean of 10 centimeters and a standard deviation of 0.03, means mu is 10 cm and sigma, which is the standard deviation, this is 0.03 centimeters. Okay, so on the basis of this information we have to find the answers of part A, B, C. So what is the statement of the part A? What proportion of rings will have inside diameters exceeding 10.05 centimeters? So this is that word x is greater than 10.75. In B, what is the probability that a piston ring will have an inside diameter between 9.97 and 10.03 centimeters? Means the probability that x is greater than 9.97 and less than 10.03 centimeters. And the last one here is below what value of inside diameter will have 15% of the piston ring, means the probability that x is less than small x or z. When we will convert it to the z domain, it will become z. So this is what, this is 0.15, or in z domain it is x is less than z, that is 0.15. Okay, so we have all the given data here, all the requirements here, and what do we have to do as we have previously done. Sorry, this is 10.075. Okay, let me remove it. 10.075, this is what we have. So all these values are in the form of x, and in order to use the z distribution table and converting it into the standard normal distribution, what do we have to do? We have to convert these values to the z, and the formula for that is here as given, that is z equal to x minus mu divided by sigma. Okay, so now for this, which is part A, what do we have to do for it? The value of z is x, which is here 10.075 minus mu, which is 10 divided by 0.03. Okay, so it is now what? It is 0.075 divided by 0.03. Okay, let me calculate it. This is 0.075 divided by 0.03. So this is 2.5. Okay, so this is 2.5. The value of z is known, which is 2.5. So therefore, now in part A, this term has been transformed from 10.075 to 2.5. So therefore, the value of x should be now greater than 2.5. And as we know that the z distribution is not made in terms of this formulation, so therefore first we have to find the value that x is less than 2.5, and then subtract it from 1, we will get our answer. So let me find out this value, which is x is less than 2.5. This is the z distribution table, this is 2.5, and here the answer is 0.9938, 0.9938. Okay, so let me subtract it from 1 minus 0.9938, and this is what, 0.0062, and that is what, that is basically the solution of part A of my question. Okay, this is the solution of part A. In part B, what is the probability that a piston ring will have an inside diameter of between 9.97 and 10.03 centimeters? This is again given here. This is part B. Let me solve it here. This is part B, and here in order to do so, let me call it x1. This is x2. Okay, and first we have to convert them to z1 and z2. So z1 is equal to x1 minus mu divided by sigma, and z2 is what, x2 minus mu divided by sigma. Okay, so in order to find them out, the value of x1 is 9.97 minus 10 divided by 0.03, and the value of z2 is what, that is 10.03 minus 10 divided by 0.03. Okay, so how much would it be? The value of z1 would be what, that would be 0.03. Okay, that is 0.03, but now here this is minus and this is 0.03, and here it would be z2, this is positive 0.03 divided by 0.03. So therefore in the basis of this formulation, the value of z1 is 1, the value of, sorry, the value of z1 is -1, the value of z2 is 1. These are the values. Okay, so this formula is now transformed into what, that is now the probability that x is greater than -1 and less than 1. This is the formula. Let me solve it here. This is the solution. So in terms of z, it is greater than -1 and less than 1. And to find it out, we have to find here that x is less than 1 minus the probability that x is less than -1. Let me find out these values. So x is less than 1, that is here 0.8413, 0.8413 minus the probability that x is less than -1. So less than -1 is, this is here 0.1587, 0.1587. Okay, so here first let me calculate it. So 0.8413 minus 0.1587, this is 0.6826, 0.6826. Okay, is this the answer? Yes, and that is what, that is basically the solution of part B of my question. Now in part C, below what range of inside diameter will 15% of the piston ring will fall? Okay, so to solve it, let me first remove these parts. As I had written here that this is part C, that the probability that x is less than z, that was 0.15. Now in order to find the value of this z, we have to take the inverse z transform of 15. We have to look in the table that what value of 0.15 corresponds with the value of z. So let me take you to this table and let me search for 0.15 here. Okay, so these are all the values for 0.15, and that is here. This is around 0.15 and it is minus 1.4, minus 1.04. Okay, so that is minus 1.04 because this is minus 1.0 and this is in the fourth column. So therefore let me write it. So the value of z is minus 1.04. Okay, we have got this value. In order to convert it to the relevant x value, so we knew this formula. From it we can very easily see that x is equal to what, that is mu plus c multiplied by sigma. So the value of mu is 10, the value of z is minus 1.04, the value of sigma is 0.03. Okay, so this would be 10 minus what, 1.04 multiplied by 0.03, this is 0.0312 minus 10, this is minus 9.969, which is here. This was something which we had calculated and then carried out this step as well. So the overall answer here is 9.97, and that is what, that is the 9.97 centimeters, which is the value of diameter which will have 15% of the piston rings fall. Okay, so that is what, that is the solution of part C of my question. That's it for today. If you have any question, please don't hesitate to ask me in the comment box. See you soon. Welcome back, guys. This is question 6.15, and the statement of this question is: a lawyer commutes daily from his suburban home to his midtown office. The average time for a one-way trip is 24 minutes with a standard deviation of 3.8 minutes. Assuming the distribution of trip times be normally distributed. Okay, this is information we are given, means the mean is 24 minutes time and standard deviation is what, that is 3.8 minutes. Okay, so this is also mu and this is sigma. Okay, and it is also given that the distribution of trip time is normally distributed. So on the basis of it, we have to find the answers of part A, B, C, D and E. So let us start part A. So in solving part A of our question. What is the probability that a trip will take at least half hour, means 30 minutes? Okay. So we want to find the probability that x is greater or equal to 30. Okay, so I am neglecting this minute because all the quantities here will be in minutes unless and until these are converted to z. So here we have to find this probability by using the z distribution, where it would be 1 minus the probability that x is less than 30. So therefore we have to convert this 30 to z. So therefore z is equal to x minus mu divided by sigma. This is the value of x for now, so writing it here. So 30 minus 24 divided by 3.8, this is 6 divided by 3.8, which is what? 6 divided by 3.8, this is 1.58. Okay, this is 1.58. So that is what we have. So therefore this will be what? Now let me use another colors for this. This will become in the transformed form. It will be probability that x is greater or equal to 1.58. It would be 1 minus the probability that x is less than 1.58. Okay, so we have to find the probability, which is this one. Why did we convert it to this form? Because we know that this is the form, this one is also the form. When it is transformed into this one, this is now the value of z, and this is the formula in which the z distribution table has been developed. So therefore we have to find it out in terms of this. X is less than 1.58 and then subtract it from 1. So let me find it out from the z table. So 1.58 is 1.5 is here, this is 1.5, and 8 is here. This is the column for 8. So therefore the value for 8 is 0 0.9429, 0 0.9429. Okay, and subtracting it from 1 minus 0 0.9429. So what we will get, it is 0 0.0571, 0 0.0571, which is around 5.71%, and that is what? That is the probability that x is greater or equal to 1.58 in the transformed form. And in x form, it is now, what is the probability that he will take at least 30 minutes, and this is what? This is the probability and the answer for it. Okay, this is the answer which is here for it. Okay, so that is the solution of part A of my question. In part B, if the office opens at 9 a.m. and the lawyer leaves his office at 8:45 daily, what percentage of the time is he late for work? Okay, so what is given here in part B, we want to find the probability that he is leaving at 8:45 and office will open at 9 a.m. so he has to reach before 15 minutes. If he will reach after these 15 minutes, he will be late. So therefore it will be the probability that x is greater than 15, and therefore it is 1 minus the probability that x is less than or equal to 15. Okay, so therefore what we have to do, again, this is the value of x, we have to convert it to z by using the same formula which is here. Okay, so let me have here z is equal to x, which is 15, minus mu, which is 24, divided by 3.8. so it is minus 9 divided by 3.8. so 9 divided by 3.8, this is this 2.37. so this is minus 2.37, and this is the value of z. Now let me put them here. It would be 1 minus the probability that x is less than or equal to minus 2.37. okay, this is what we have. Now let me move down somehow, and here 1 minus probability that x is less than or equal to minus 2.37 from the z distribution table. So minus 2.3 is, this is minus 2.3, and the column for 7 is this one. So minus 2.37 is 0.00889. So 0.00889, subtracting it from 1, it will be 1 minus 0.00889. This is 0.991. So 0.991. So this is around 99.1%, and the chance of getting late is 99%. Okay, so that is what, that is the solution of part B of my question. In part C, if he leaves the office at 8:35 and the coffee is served at the office from 8:50 until 9 a.m., what is the probability that he misses coffee? So this is what, again, if he is leaving at 8:35 and the coffee time will be ended at 9 a.m., so therefore if he will reach after these 25 minutes, means he will miss the coffee. So therefore here we want to find out the probability that his time of reaching the office is greater than 25. Again, it is 1 minus probability that x is less than 25. Okay, again we have to change it to z by using the same formula, putting the values here, then and then finding the answer of it by subtracting it from 1, and the answer of it will be 0.3974. That is what, that is the solution for part C of my question. So these are the three parts which we have discussed so far. So let me remove these now, and then we will proceed to part D. So in part D, find the length of time above which we find the slowest 15% of the trips. Means the slowest 15% of the trips are, here we can see that if this is the distribution, if this is the normal distribution of the trip and this is the mean value which is 25 minutes, this is the standard deviation which is 3.8 minutes. Okay, and the slowest of it will be here, and let me call it x, and the slowest ones here are, these are the 15%. Okay, because here the more time will take from the mean to the right, the more time a person will take a trip from his home to office. So therefore this is the 15%, and this is what, this is the slowest 15%, while these are, let me use another color, this black one. Okay, while this one, this remaining one is what, this remaining one is the 85%. Okay, so therefore this is the lower one than this one. These 85% are the lesser one from this one. So therefore here we want to find out the probability that x is less than or equal to this small x, and it is this lowest one, because in the formula we have to choose the less than or equal to relational operator. So therefore this is the 85%, and therefore we have to find this 0.85. Also, in terms of the z distribution, where it will be normalized, and here this mean will become 0 while the standard deviation will become 1. Okay, because this is the z distribution, standard normal distribution, therefore here we will have this z value, this is now the 15%, while this remaining ones are the 85%. Okay, so therefore if you want to find out in terms of z, we will have to find this x is less than or equal to z, while this area will remain the same, which is 85%. In order to find the value of this z, what do we have to do? We have to have the z and find the inverse of 0.85. What do we have to do? We have to move to the z distribution table, look for the 0.85 value and see that which value of 0.85 corresponds with the z. So therefore let us move to the z distribution table. So where is 0.85? Let me move down here. So 0.85 is this one. This is the 0.85 and it is 1.0 in the row. Sorry, this is 1.0, and in the column we have this 0.4. So it is 1.04, and this is what we have the value of this z. So z is 1.04. Okay, so this is the value of z. So find the length of the time. So therefore we want to find out the value in time, which is here. So after first we have moved from here to here. After transforming it, we have to transform it back into this x. So therefore it is now x equal to mu plus z multiplied by sigma, which is from the formula, which is z is equal to x minus mu divided by sigma. From it we have found it out. Mu is 24 plus z is 1.04 multiplied by this sigma, which is 3.8. Okay, let me find them out. So it is 1.04 multiplied by 3.8. This is what? This is 3.95 and plus 24. So this is 27.95. Okay, so the answer of it is, let me write it here, 27 point what? 95. So this is the time, or the time for it is 27.95 minutes. Okay, so this value is 25.95 minutes, and after it will be here. Okay, so that is what, that is the solution of part D of my question. Let us move down for part E of my question. Let me change the color. So find the probability that 2 out of the next 3 trips will take at least 1 or 2 hours. Okay, means we are having 3 trips, and out of them 2 of the trips will take 1/2 hours. So first of all we have to find the probability that, what is the probability that the delay will be of 0.5 hours or 30 minutes. Okay, means we have to find the probability that x is greater than 30, and which we have already found out in our part A, and that was what? If you remember, it was 0.0571. This is the probability for it. If you have some trials, and out of those trials you have to find the number of trials which have some probability given, then this is basically the problem of the binomial probability. Okay, so therefore in order to find the value here, because we have this p is 0.0571, we have now q, which is 1 minus p, and 1 minus p is 1 minus 0.0571. So that is 1 minus 0.0571, that is 0.9429. So 0.9421, that is the value of q. So therefore now in order to find the probability that out of the 3 we have 2 rides which are 30 minutes or more than that. So therefore in order to find that out, we have here k equal to 2 out of 3. So therefore the formula for it was, let me call it nk, p of k and q of n minus k. Okay, so now writing these values, the value of n is this one, the value of k is 2. So 3 choose 2. The probability value is here, that is 0.0571 raised to the power 2, and q is 0.9421 raised to power n minus k, which is 3 minus 2, and that is 1. Okay, so let me find them out, it is now 3 factorial divided by 2 factorial and multiply 3 minus 2 is 1 factorial. This is now 0.0571 square and 0.9421. Okay, this will become what? It will be 3 multiplied by 0.0571 square and 0.9421. Okay, so calculating it and finding the answer of it, what we will get, the answer of it will be 0.0092, and that is what? That is basically the solution of part E of my question. Okay, so that's it for today, in which we have seen the solution of question 6.15. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 6.17. And the statement of this question is the average life of a certain type of small motor is 10 years with a standard deviation of 2 years. Okay, mean is given, which is 10, and the standard deviation, which is sigma, that is 2. The manufacturer places free all motors that fail while under guarantee. If she is willing to replace only 3% of the motors that fail, how long a guarantee should be offered? Okay, means this 3% is what? That is the probability, which is the probability that X, and in order to find it out, let me have here Z, which is the similar one as that of X but in the Z domain, and the probability it has is 0.03 because of this 3%. So if he is willing to replace only 3% of the motors that fail, how long a guarantee should be offered? Okay, means I want to find out the guarantee, which is this Z. Assume that the lifetime of a motor follows a normal distribution. Okay, we have assumed it as well here, because this is what we have been doing since our previous questions. So therefore this is what we have now here. In order to find it out, what do we have to do? We have to find out the Z from here, and for it we have to find the inverse Z transform of 0.03. Okay, so this is 0.03, and let me find it in the table. So what is the, where is the value 0.03, which will correspond with the value of Z, and we will write it there. So 0.03, all of these values are 0.03s. Okay, so the lowest of them is, so this is the lowest one, 0.03 minus 1.8 in the row, and in the column we have 0.08, so this is minus 1.88. okay, so therefore let me write here the value of Z is minus 1.88. okay, so from it we have to find the value of X, and we previously have known that Z is equal to X minus mu divided by sigma. From it the value of X is mu plus Z multiplied by sigma. Let me write the value of mu, that is 10, plus the value of Z, which is known, minus 1.88, and multiplying with the sigma, which is 2. Okay, so it would be 10 minus 1.88 multiplied by 2. Okay, so 1.88 multiplied by 2, this is how much? This is 3 point what? 3.76. okay, subtracting it from 10 minus 10, we will get 6.24. so the answer is 6.24, and that is what, that is basically the solution of question 6.17. and as these are all in years, so therefore these are 6.24 years. okay, so that's it for today, in which we have seen the solution of question 6.17. If you have any question, you can ask me in the comment box. See you soon.